And when you have two graphs, the solutions are your points of intersection, basically, always. It doesn't matter what kind of functions you're dealing with. If they want the solutions of 2 equations or 3 equations or 4 equations, you're looking for the points of intersection. How about look? Look for points of intersection. Those are your solutions. After we get done, they want us to write an equation that would show where all these are. So that's actually easier than you might think. We're just going to, basically to write the equation, we're going to set those two equal to each other and move all the terms to one side is all we're going to do, okay? So if you've got your calculator out, we're going to go to the y equal part. I'll tell you what, let's put our calculator in radians, so you might check to see if you're in radians. Because we're going to be graphing some equations, and it would probably be best to do it in radians. Let's see. Yeah, they're telling us to do it in radians. What was that? Zach?
Someone was just murdered.
Sounds like Zach.
Well, I saw the seniors leave to go somewhere, so I don't know where.
They're just really happy. Okay. Okay, so it's sine 2x, so inside the argument, that part after the sign is called the argument. Oh, you can't see this. Sorry, I forget that you can't see my calculator.
What?
X squared.
Throw it in the trash can, it's gone.
It's gone?
Yep.
Yeah.
Okay.
Some leprechaun ate it.
Yeah.
Okay.
Probably one-eyed and black, I don't know.
So if we put those on different lines of y equal, and then you hit graph, if you put it in radians, it looks a little nicer than if you left it in degrees. You can see a lot more. So how many points of intersection do you see once you hit graph? You may not be there yet, but look once you get there. How many?
Two.
It's going to be 2. How'd you know?
Because of the way the thing is. I don't know why.
Okay.
I don't know.
It is 2, and x squared, I guess maybe the x squared could have told you might expect 2. It can vary, though. If you kind of look at what's going on, you've got your sine coming in and doing this sort of thing. And then you've got, then you've got your x squared minus 2x. That's a parabola, right?
Did you print your own chapel schedule today?
I didn't print it out.
Okay, well, there it is right
Thank you. Good. We were wondering. I was like, oh, shoot. Okay, so the parabola is like, it's doing something like that, if you see it. So there are 2 solutions. The solutions are right here and right here. And so to find them, y'all know how to find those on the calculator. You hit second, and then the trace button, because we're trying to get to the calc function, and it's that blue, it's in blue above the trace button. So second calc, and we're looking for points of intersection, so we're going to choose 5. Now we can only do 1 point at a time, so we're going to have to do this whole process twice. So I'm going to choose 5 for intersect, and then this is one of those things, you're just going to move the cursor over one of the intersection points and go enter, enter, enter. And so we get one intersection point is 0, 0, and that, if you're looking at your calculator, that looks like what it's saying, okay? And then the next one, second, we're going to do it again, second trace 5 again. And this time we want the other point, so we're going to move our cursor with the left arrow over to the other point and try to place it over as close as we can to the point of intersection. And hit enter, enter, enter. I'll put that on here, bless you. And here's what I'm getting, and y'all tell me if you got the same thing. Let's say we round to the hundredths, okay? So 1.78 is your x, and your y is negative 0.398, which would round to 0.4. And I could put a 0 there just to show, yeah, I really did think about the hundredths, but I rounded it to 40. And so that's how we would just do it. It's real easy. Anytime, like if you're on any kind of admissions test or something, because even though you have all the classes that you take in high school, a lot of times they'll make you take a placement test. anytime they ask you for like the solution of two equations, you can just do this second trace 5, put your cursor over it, enter, 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 and you got it. It's one of the easiest things to do on the calculator. So the next thing they asked us to do was to write the equation that shows the solution. So we're just going to set those two equal to each other, because that's what we're saying is where are the points where those two have a shared value, right? So on part B, you just set them equal to each other, and it was sine 2x equal x squared minus 2x. And, honestly, it's not wrong to leave it that way, but probably we would just subtract sine 2x from both sides, I guess. I'm guessing this is how the book would write it. Just knowing how textbooks tend to do things. 0 equal x squared minus 2x minus 2 sine x would be an equation that would give you those solution points. If you wanted to try to work that out algebraically, I wouldn't. That doesn't look very pretty, does it? Not something we'd want to try to have to solve, but we could. Okay, so what you want to do here is you want to get the trig function by itself, right? That's kind of the big idea here, is get the trig function by itself. I'll write that on here. Okay, so what's the trig function here that I'm talking about? Well, the tangent is the trig function, right? So I want to get the tangent by itself. Yeah. So actually, I need all that. I'll need all that with it, but probably at the end, since this is squared, I'll probably take a square root at the end, right?
Lump the 2x with it.
Huh?
Lump the plus 2x with it.
Yeah, because that's the argument of the tangent. So in a bit, we'll be breaking that apart a little more, but that's a little bit further on down. So let's move the 1 and the 3 over. We would move the 1 first by adding it. So we would have 3 tangent squared 2x equal 1. And then we could divide both sides by 3. Tangent squared 2x equal 1/3. And now what do I do? Well, I'm going to square root first, right? Because I've got that trig function squared, so we're going to square root both sides. And when we do, we get tangent of 2x is equal, square root of 1 is 1, and on the bottom we have square root of 3. And if I rationalize that, isn't that square root of 3 over 3? Okay. Now, remember yesterday, one of the things we did when we got started was we made that little chart with sine, cosine, tangent, and then we had 30, 45, and 60, right, so we could see it. Let's see. Okay, so we made our little chart, and we know that the angle that we're talking about, the tangent of 2x, has to be, let's put it in radians, because we're supposed to be doing this in radians. 30 degrees is pi over 6, because 180 divided by 6 would be 30, right? Okay. Now, so here's what we're saying. Oh, wait a minute. The tangent, sorry, I shouldn't have done that. The tangent of 2x is square root of 3 over 3, but what we know is that that's a 60-degree angle, a 30-degree angle, which is pi over 6, so we would say 2x is actually, the angle is pi over 6, but they put 2x here, so I'm going to say 2x is pi over 6. How am I going to find out what the actual real solution is here? Aren't we just going to solve for x like we normally would, right? So we multiply both sides by a half to get rid of the 2, and x would be pi over 12. Well, looky here. Here's x, and look at that. That's the first solution. So you have to actually do the algebra. You don't just get your calculator out, or you don't just plug it in and just, flip through the thing. You really actually have to algebraically solve it and get this. Because isn't this your reference angle now? Okay, so I have a positive tangent, correct? What else should I draw on my paper to help me see, what about this 5 pi over 12? Where does it pop in? How am I going to get it? What should I be drawing somewhere here? If I draw that little all students take calculus, pi over 12 is over here. It's positive. Where else would the tangent be positive? What quadrant?
3.
I'm gonna do something funny to you if you fall asleep. Just 'cause it's just so tempting.
Resting my eyes.
I understand, it's early.
Hands are missing.
So, all right. So if it's positive, that means that reference angle's over here in the third quadrant, right? Because that's where tangent is also positive, is in that third quadrant. We know it from our little naming device if we don't want to think about the positive x's and y's and negative x's and y's. So this kind of gets us out of having to use our brain too much. So if tangent's positive there, wouldn't that be pi plus that pi over 12? Isn't that what we could say that angle is? Right? Because it's all the way to pi and a little bit past it. As a matter of fact, it's pi 12's past it. So if I want to say pi plus pi over 12, oh, actually, you see, let's do this. I need to do something a little bit different here. This 5 pi over 12, I need 2x to be equal to, that's, okay, square root of 3 over 3. That's the reference angle. I'm getting a They write x equal 5 pi over 12. They actually go ahead and they plug it in. I guess sometimes maybe it's harder to find. I was trying to show you how to find it on your own, but they don't even try to do that. So maybe I shouldn't have either. So tangent of 10 pi over 12, oh my word, because they doubled the 5 pi, so in here they plugged in 2 times 5 pi over 12, and that got them the 10 pi over 12. And so the tangent of 10 pi over 12 squared minus 1, okay, so 10 pi over 12 would be a 1/6 pi short. So it's short. Why would it be over here? All students take calculus. I guess the fact that they're squaring it, I don't know. I was in the wrong quadrant working, apparently. So I guess here they did just want us to verify what they were doing here by plugging it in. Okay, so this would be pi over, oh, I see what happens here. It's pi over 6 short, right?
Yeah.
Okay, so the tangent of that would be, what's the tangent of 30 degrees? It's square root of 3 over 3, but it's negative in that quadrant. So it would be square root of 3 over 3, but it's negative. But when you square it, what happens? It becomes positive. Okay. So actually, because of that square, probably any reference angle of 30 degrees or pi over 6 would work here, because whatever you get, you square it. Oh, this is confusing. So that would be 3 over 9. 3 times 3 over 9 minus 1. Well, 3 times 3 over 9 would be 9 over 9, which is 1. Minus 1 would be 0. 1 minus 1 is 0.